I am Dr. Pankaj Dadich from SKIT Jaipur. Today I am giving a presentation on distributed systems. This is the outline of my presentation. What is a distributed system? Examples of distributed system, common characteristics, basic design issues and summary. So what is a distributed system? A distributed system is one in which components located at network computers communicate and coordinate their actions only by passing messages. It requires autonomous computers to be interconnected through a network. Each computer has to be equipped with distributed operating system software which enables the computers to coordinate activities and to share resources in a controlled way. This definition leads to the following characteristics of distributed systems: concurrency of components, lack of a global clock, independent failures of components. To clarify the consequences of a distributed system, we compare its characteristics to those we find in centralized systems. In a centralized system, there is a single component that may be decomposed further. However, its parts, such as classes in an object oriented program, are not autonomous. The component possess full control over them at all times. As there are no other components, there is no need to provide an interface to the component. If the component supports multiple users, the users share the complete component at all times. A centralized system runs in a single process. There is no need to take concurrency control and synchronization into account. Software runs in a single process and single point of control and single point of failure in centralized system. While in distributed system, there are multiple components that may be decomposed further. These components are autonomous. They possess full control over their parts at all times. The components, however, have to provide interfaces to be able to use each other. Components are not shared by all users. Resources may not be accessible, and software runs in concurrent processes on different processors. In distributed system, there are multiple points of control and multiple points of failure. These are the examples of distributed system: a local area network and intranet, database management system, automatic teller machine network, internet, the World Wide Web, mobile and ubiquitous computing. Local area network. A local area network consists of a number of different computers. Workstations and personal computers provide the front end for network users. Different servers provide shared services. One of several network file servers provide data storage services. A local name server maps machines names to IP addresses, usernames to user IDs, and group names to group IDs. Local area networks can be connected together to form intranets. Next example is database management system. Different client applications want to access and update shared data in a database. So client applications might be banking systems, real estate agencies, airline ticket reservation systems, accessing data like balances of bank account, detail of property that are for sale or to let, or airfares and aircraft reservation data. The database is physically distributed over several processors to take advantage of local data accesses for increased performance of client applications. Next is automatic teller machines. An automatic teller machine network enables bank customers to withdraw cash from their bank account. Next is internet. Internet is the largest distributed system in the world. World Wide Web. World Wide Web is the largest software application running on internet. It becomes the most popular distributed software application ever created. Next, web servers and web browsers. A web browser is a user interface to the world's biggest distributed system, such as the internet. And a web page includes links to other web pages. These links are specified as URLs. Next is mobile and ubiquitous computing. Mobile and ubiquitous computer extend the access of internet and distributed system architecture from wireline connections to wireless connections. These are the common characteristics: heterogeneity, openness, security, scalability, failure handling, concurrency, transparency. So, first one, heterogeneity. In heterogeneity, the internet enable users to access services and run applications over a heterogeneous collection of computers and networks. There may be a variety of networks, different types of computer hardware, different type of operating systems, different type of programming languages, and implementations by different developers. Middleware helps to solve the problems of heterogeneity. It also provides a uniform computational model for use by the programmers of servers and distributed applications. Mobile code to refer to code that can be sent from one computer to another and run at the destination. Example, Java applets and Java virtual machine. Next, openness. Openness tries to address the mm, openness tries to address the how to improve the system, how we can extend the system, such as most often functional extensions and improvements require new components to be added. These components may have to use the services provided by existing components. Hence, the static and dynamic properties of services provided by components have to be published in detailed interfaces. So, components may not always be running on the same platform. To achieve such an heterogeneous integration, often different data representation formats have to be integrated. Next, security. Security. Many needs for security exist for distributed system for data secrecy and personal privacy. Security is also required for authentication purpose. Many challenges in security exist in modern distributed systems. Denial of service attack and mobile code security are the examples. Next, scalability. In scalability, distributed system can be built in such a way that there are they can adapt more users, then accommodate with more users or respond faster. Usually done by adding more and faster processors. However, components in distributed system have to be designed in a way that the overall system remains scalable. Next, failure handling or fault tolerance. Hardware, software, and networks are not free of failures. They fail either because of software errors, failures in the supporting infrastructure, such as power supply or air conditioning, misuse of their uses, or just because of aging hardware. So the average lifetime of hard disk are between 2 or 5 years, much less than the average lifetime of distributed system. So distributed system therefore have to build in a way that they continue to operate even in presence of failures of some of its components. A distributed system can even achieve a higher reliability than a centralized system if distribution and replication is exploited properly. So fault tolerance is achieved by recovery and redundancy. Next is concurrency. In concurrency, components in distributed systems are executed concurrently or simultaneously. They may be many different people at different teller machines. There are many different users working in a local area network. While these components access share resources, the resources have to be protected against integrity violations that may be introduced through concurrency. So, Components access and update shared resources, example variables, databases, device drivers. Next is transparency. So the complexity of distributed systems should be hidden from their users. They should not have to be aware whether the system they are using is centralized or distributed. Thus, it is transparent for the user that he or she is using a distributed system. There are various types of transparencies. First, access transparency. Access transparency means that the operations or access transparency means that the operations or commands that are used for accessing objects are identical regardless whether local or remote data is being accessed. Uh, Examples of access transparency are file system operations in network file system, navigation in the web, SQL queries. Next is location transparency. In location transparency, it enables information objects to be accessed without knowledge of their location. Means that data can be accessed without knowing the physical position of the data. Examples are file system operations in network file system, pages in the web, and tables in distributed databases. Next is concurrency transparency. It enables several processes to concurrently access and update shared information without having to be aware that other processes may be accessing the information at the same time. So, examples are network file system, automatic teller machine network, database management system. Next, replication transparency. Replications is the duplication of data on other hosts. Replication is used to increase the reliability of data access as well as the performance with which data is accessed and updated. So, replication transparency denotes the fact that neither users nor application programmers have to be aware about the replication of data. Examples are distributed DBMS or mirroring web pages. Failure transparency. It enables the concealment of faults. Even though components in distributed system may fail, it is important that users of the systems are not aware of these failures. So, failure transparency denotes this concealment of failures. Failure transparency is rather difficult to achieve. It involves complete fault recovery. Example, database management system. So, in database, if the database has kept local replicates of remote data, users can continue to use the database even though the remote data monitors have failed. Next is mobility transparency. Migration denotes the fact that software and data is moved to other processors. So migration is transparent to users and application programmers if they do not have to be aware of the fact that software and or data has moved. So migration transparency is dependent on location transparency. So the movement of information objects, it allows the movement of information objects within the system without affecting the operations of users or application programs. Examples are network file system and web pages. Next is performance transparency. Performance transparency denotes the fact that users and application programmers are not aware as to how the performance that a distributed system has is actually achieved. Examples are distributed Mac. Next is scaling transparency. Scalability denotes the fact that the distributed system can be adjusted to accommodate a growing load number of users. So, scaling the distributed system up is transparent if users and application programmers do not have to be changed. So, it allows the system and applications to expand in scale without change to the system structure or the application algorithms. Examples are World Wide Web and distributed database. Basic design issues. Software engineering principle includes rigor and formality, separation of concerns, modularity, abstraction, anticipation of change, generality, incrementability, incrementality, so on. So there are some specific issues for distributed systems such as naming, communication, software structure, system architecture, workload allocation, consistency maintenance. So naming. Uh, a name is resolved when translated into an interpretable form for resource object reference, such as communication identifier. It consists of IP address and port number. Name resolution involves several translation steps. Next, design considerations. It is the choice of namespace for each resource type. Name service to resolve resource names. Mm, Name service include naming, context resolution, hierarchical structure, resource protection. Next, communication. Synchronization prevents sending or receiving process from continuing until the other process makes an action that frees it. So, separated components communicate with standing processes and receiving processes for data transfer and synchronization. Message passing includes send or receive primitives, synchronous or blocking, asynchronous or non blocking. Abstractions define channels, sockets, ports. Communication patterns such as client server communication, example RPC, remote processor call, function shipping, and group multicast. Software structure. This is the layers in centralized computer system where topmost layer is applications. Middleware provides runtime support for programming language such as interpreters and libraries. Operating system is the main system software to manage basic resources and to provide user and application services. And last bottommost layer is the computer and network hardware. Layers and dependencies in distributed system are shown here, where applications are the topmost layer. Then middleware consists of distributed programming support, open services. Then operating system consists of open system kernel services. Kernel only perform basic resource management with the addition of inter-process communication. And the last one is computer and network hardware. So distributed programming support includes runtime support for language facilities that allow programs written in conventional languages to work together. These are the system architectures: client server architecture, peer to peer architecture, services provided by multiple servers, proxy servers and caches, mobile code and mobile agents, network computers, thin clients, and mobile devices. First one, client invoke individual servers. So there are clients and servers. Client invokes a request to server and server respond a result to the client. A server may be in term a client behave like a client to other server. So it can also invoke a request and get a result from other server. So process is denoted by ellipse and rectangle denotes the computer system. Next, peer-to-peer systems. A computer system process can directly communicate with another computer system process. So it is known as peer-to-peer communication, such as shown in the figure. The peer 1 directly communicate with peer 5 and peer 4, and peer 2 directly communicate with peer 4 and peer 3. So this is peer to peer communication. A service by multiple servers. There are clients and there are multiple servers such as internet server, file server, and then database server, antivirus server. So the clients are accessing multiple services from different type of servers. Next, web proxy server. So a proxy server is created between a web server and a client. If a client needs any data, then it can interact with proxy server. So if a proxy server have the data, then it will directly provide to client. If it is not having the data, then it can contact to web server and provides the data from web server to client. Next is web applets. So in web applets there are this is following two step process. First step, client request results in the downloading of applet code. Client request from web server applet code, and then web server provides applet code to the client. In second step, client interacts with the applet. Client directly interacts with the applet and web server remains separate. Next, thin clients and compute servers. So a thin client is a low cost endpoint computing device that relies heavily on a server for its computational role. The term thin client is also used for describe software applications that use the client server model, in which the server performs all the processing. So thin client is communicating via network to the compute server or application process. Thank you. This is all from my side.